So it's been a while since I've been in front of the whiteboard. I've been doing live streams lately. If you've been following me, if you're watching this in the future, you have no idea what I'm talking about. But I'm going to go back to the whiteboard here. I'm going to try to make more of these videos. In this one, I'm going to elaborate on something I covered in a live stream. I know the live stream format isn't for everybody. This format you're going to hear is kind of edited and a little quicker to get through the material. But what I want to discuss is converting plus or minus locations to position locations. So if you have old drawings that have locations with plus or minus, and you want to kind of update them to have GD&T on them for whatever reason. And I'll show you how we go about that. So let me posit the scenario here. So the simplest possible case is going to be a hole on a plate, right? Now, if the plate is really thin, like sheet metal or something, it's possible you don't even need GD&T at all, right? Because there's no thickness. GD&T is real convenient when you have like a thicker part, so like a machine part. GD&T is going to give you, some information about the perpendicularity of a hole, whereas this is going to have a tough time doing that. What do I mean? I mean, if the part is really thick, right, and say the hole is crooked, are you taking these measurements from here or from this side, right? Because it's going to affect, what you get here. It's also going to be difficult to figure out if this orientation error is okay or not. It's just kind of a can of worms. Now, I've gotten this question a lot, right? So how do I convert, and what do I use? Do I just put this number in the feature control frame? And I've seen people do that. They'll say, okay, well, it's plus or minus 20 here, so we'll just put 20 here. Oh, wait, am I in the way? We'll put 20 here, or we'll put the total tolerance, which would be 40 thousandths, or we'll put the tolerance of the diameter. It's going to be wrong in every case, and I'll show you why in a second. I didn't even put a tolerance for diameter here because it doesn't matter for a location right now. So in GD&T or ASME, I shouldn't say GD&T. Well, ISO is GPS, but in ASME, GD&T, the beauty of this is we're going to separate the size of the feature from the location of the feature. You can sort of do it here, but you lose out on the orientation aspect. And when we get into and we won't today, but when you get into patterns, position can control everything all at once, which is convenient. Okay, so we're going to convert this over in just the simplest possible way. We'll make A the board, B one side, C the other side. These plus or minus dimensions become basic, but we're going to keep a plus or minus dimension for the hole, because that's going to be our feature of size. Now, we need this number. This is probably the most asked question I get. Like, what is this number supposed to be? If you're doing like a new assembly, you can use the floating or the fixed fastener formula. I think I have like old videos where I talk about it, but I'll make new ones at some point. Okay, so let's investigate what's going on here. In this situation, right, what do we have? We essentially have a square that's 40 thousandths on either side, right in the middle of that tolerance zone. So let's draw that real big, where each of these ticks is 10 thousandths. So 10, 20. Essentially got this big square, right? That's 40 thousandths on each side. And the axis of this hole, well, I say axis, center point, it's really not clear with plus or minus dimensions. The center of that feature, let's say, needs to be within this tolerance zone, right? It's pretty easy to verify, right? It's either, you're checking it in the Y direction, the X direction or the Y direction. It's either good or it's not. And that's one convenient thing. You literally can just check it with a tape measure. If you can, I don't want to say that. You can check it with a tape measure if you can simulate, right, the center of that hole. Okay. So what we're doing with position that's different is that by default, well, I don't want to say by default, if we put this diameter symbol in our position feature control frame, it's telling us that the tolerance zone is cylindrical. Now, I say by default because you can have a square or a rectangle or like even a wedge-shaped tolerance zone, but it's not as easy as just not having this in there, right? If you don't put a diameter symbol, the meaning is not clear, right? And as far as I know, there is no support for the square symbol. Now, if you're using that on drawings and it works great and your vendors are happy with it, please, DM me, let me know. I'm really curious to know. I mean, it seems like it would work fine, but the way I know how to do it is if you needed a square tolerance zone, you've got to have one feature control frame coming from this direction and one from this direction, and then each of them would have just a value, right, with nothing before it. Okay, so that's why I say the diameter is kind of the default. You just have to get used to adding that symbol in your CAD program. Okay, check it. Our actual, all right, so what we want to put in here needs to match up with this, right? Well, this is a cylinder, this is a square. There's two ways to do it. I'd say probably the most common, well, I don't want to say the most common. I'd say the conservative way to do it is to, I should be able to get this right, inscribe the circle to this square. So you're essentially getting a diameter of 40 thousandths, right? I know I said that was wrong earlier. I said that was wrong because you're just picking from the thing, but the diameter here, radius 20, diameter of 40 thousandths. That would encompass this area. Now, the problem is you've got these little trouble zones, right, where before it might have been acceptable. Now, I think most people would agree with me that it's extremely unlikely that like you have this part that works great forever just because it has a square tolerance zone and somehow the machine is making them all in the corners somehow, but it's a possibility, right? So maybe in some world you could have parts that get rejected now, but they weren't getting rejected before. Okay, the other way to do this is to draw the circle around the square. So you're inscribing the square in the circle, I think, if I can remember that correctly. So the diameter of this, right, we got to find out what this hypotenuse is. I want to say it's 28 thousandths. Right, it would just double that. That's going to be a diameter 0.056, right? That would be the optimistic way to tolerance this. So you're saying, okay, well, we're okay. If the part was, let me draw this again. Okay, so I'm trying to get out here. If you've been through like a GD&T class, you've heard this before, right? If the part is good, if it lands on one of these hypotenuse areas, it's also good if it's over here, right? So notionally, it shouldn't make a difference as far as the functionality of your parts. Shouldn't, but you gotta check your design and make sure you can fit it. This would be, right? I know I just erased it, but this would be a diameter tolerance zone of 56 thousandths. So we're saying from plus or minus 20 thousandths location, one answer is 56 thousandths position diameter. The other answer is 40 thousandths position diameter, depending on how you want to go there. So I'm going to end it there. I'm going to make a whole other video about bolts hole circles. It isn't so easy if you have a part that has holes around a circle, so you've got a bowl hole circle tolerance and an angle tolerance, that might require a special position to really transfer the design intent. But that's it for this video. If you enjoyed it, please like and subscribe. Leave a comment below. Let me know what you think about this. And try to catch me on next live stream. I'm trying to do them Mondays at 5 o'clock Eastern Standard Time.